Okay, it's time to start. So welcome to our talk on graphical views for web-based modeling tools with Theia and Sprotty. I am Miro, this is my colleague Jan from Typefox. In this talk we are going to take a rather high-level approach to this topic given by this rather long title. So we would like to share a bit of our experience and lead you to a few questions that we believe are very important to clarify before you start implementing a new graphical tool. So yeah, let's start maybe kind of a journey where we imagine we are going either to migrate an existing graphical tool from an earlier platform like Eclipse RCP to a web platform or to even create something completely new. So let's see at what technologies are we going to take. So our recommendation, of course, would be to have Theia as IDE framework as a basis. So Theia, probably most of you have heard of that. It's an IDE framework and not an IDE, so it's comparable to Eclipse RCP, and that is it's very extensible. You can build your own applications with that. It's using LSP, the language server protocol, as a basis for language support. So it has already support ready for Java, TypeScript, Python, all the standard languages that are used today. And it's very extensible. You can add editors, views, commands, everything that that you already know from the Eclipse RCP. The extensibility concepts are technically a bit different, but the concept themselves are very familiar if you know what how it's done in Eclipse. And a very important strength of Theia is you can use it in desktop as a desktop application or as a web application. So with the same code base. Then let's say you want to add some graphical views or editors to your tool. Our recommendation would be Eclipse Sprotty as a base framework there. It's a framework for diagrams. You can use it in a web page, just standalone, or you can embed it in Theia, or you can embed it even in the Eclipse IDE or in VS Code. So also there you can use one code base and deploy that into different contexts. It has built-in support for client and server separation, and that makes it quite nice to integrate with existing model bases like EMF or Xtext if you want some DSL approach or something like that. And it is the base for the GLSP, which has also been presented on this conference. We won't go much into the technical architecture and so on. If you're interested in that, there are two recordings of last year's EclipseCon about Sprotty. You will find them at YouTube, and we will also share the links at the end. Just very high-level view. This is our diagram that we always showed for the high-level view of the Sprotty client architecture. I will just explain the main components. So there's something we call a model source, which is responsible for providing the content of the diagram. Then an action dispatcher, which handles events and forwards them to other components. The command stack executes changes to the diagram, and the viewer renders the diagram. Very simple. And now, quick outline of how we will continue. So first I will give a few basics about terminology like semantic model, view model. And then Jan will show you a bit of considerations you have to take. How do you determine the content of a diagram? How do you edit a model using a diagram? So there are a lot of ways how to do that, and all of these ways have their own implications. So I will start with a demo of Sprotty. Is it the leftmost one? Okay. It has stopped. I have to start it again. this application that I will show here is a dependency graph for NPM packages. And I can show it in two different variants. One is in a standalone web page, a very simple web page. Here I can type a package name, like Sprotty itself is available as an NPM package, and then I can explore the dependencies by selecting packages, and that will reveal all the dependencies. Or I can click on Resolve All to resolve the whole dependency graph. And here I have an interactive view where I can zoom in and out, I can pan, and I see the versions of the dependencies and so on. And the same thing is also available as a Theia widget. So same code base, but two different deployments. So here I have an instance of Theia. I will enlarge a bit. So here I have can open a package.json file of an NPM package. I can right-click and say open with dependency graph. And then I get exactly the same application that I've already seen, this time with a dark theme, which I can also change in Theia. But so the application is really the same code base, just embedded into a different application. Good. Now we want to do some modeling. We have a tool for that, and of course, somewhere in that tool there will be a model in whatever form. It could be XML, a CDO repository, or an Xtext DSL. And then we want a view of that that shows something graphical about that model. That view could be a rather direct mapping of what is actually in the model, but it could also be a subset that shows maybe just an overview of your model, or that where you allow users to filter down to a certain subset of elements, or you allow users to even compose the view manually by selecting which elements they want to see. And there could even be multiple views of the same model, and you could call them different aspects of your model, or projections, or viewpoints, or perspectives. So different ways to talk about that. So, and here we see quite quickly the view itself is also a model, and we talk about that as the view model, as opposed to the semantic model, which is your your main model, which has the semantic information or domain information. And creating a view out of that can be seen as a transformation, an M2M model-to-model transformation. And Sprotty supports this basic separation of model and view from the beginning. So you can use Sprotty as the viewer, and it has in its own view model, which we call the S model. So you can transform your semantic model into an S model, feed that into the Sprotty client, and then it will be sent at some point, sent to the viewer component and rendered. Let's have a quick look at how such a model could look like. So this is a very simple diagram. Let's see what components we find here. So there are 3 nodes. So we call them S node in our view model. Then here we find a compartment with some properties of this node. We call that an S compartment. Then there are S labels, like this package label and dependency label. And there are S edges, which are the connections between nodes. And S port are connection points that constrain the edges to connect to certain points around the node. This is an example of a JSON representation of the S model, our internal view model. And you find all kinds of things in here, like size information, position, options for positioning child elements, and you find type and ID information for each element, which we use to decide how to render it. And so this is just an excerpt of a larger model that I think it shows a couple of classes of a class diagram. And that is already quite a lot. So yeah, the S model can become quite large, but usually you don't ever see it or use it directly. It's just an internal of Sprotty. So Jan, please go.
All right, can you hear me? Yeah. Thanks, Miro. So you got a little bit of the basics. The next topic will be how I actually decide, or how does the user, the end user of the tool, actually decide what's showing up in the diagram. And there are really various ways to do that, and I will show you just a few and discuss what implications that has. The goal here is that you think about maybe new interaction patterns, or just, just don't do everything again as it used to be done for the last 20 years. So this is about populating a diagram, authoring a diagram, and on the implications on persistence, layout, and reconciling. And I'll give a demo. Oh, I should have prepared that. Is the font big enough? Well, there's no font currently. I'll make it bigger, I guess. Is that big enough? So we always need a bit of space, but yeah. Can you read that in the back? Great. Okay, this is an example. This is a modeling tool we built for a customer. It's based on Eclipse Theia. So you have all the VS Code-like menus and things like that. And the actual customization for this customer was to build this DSL. It's a very generic modeling language. We used Xtext to do that. So in Theia, you can then generate a language server from Xtext and integrate that as an extension within Theia. And of course, this customer, they also wanted a graphical representation. So if you listen to, if you follow what Miro said, what we need to do is we have to map this model somehow to an S model, to the Sprotty model, and this is what we did. And if you're using Sprotty, there's a very tight integration with Xtext already, because, I mean, we're coming from Xtext, and of course we want to visualize our Xtext models. So Xtext parses the text of your models into an AST, an EMF model, and that EMF model is transformed to an S model. And then we forward that to a widget in Theia, and it looks like this. Okay, this model is more wide than high because of the layout. So you see a graphical representation of the model that is textual here in the top part, and on the bottom is it's the graphics. So bear with me, the colors are part of the requirement. I would have chosen some some others, but it was there. Maybe you have to put on your sunglasses. All right, what you get out of the box with Sprotty is this synchronization. So if you're using Xtext and Sprotty, I can select a class in my text, and you see all the diagram focus changes to the representation in the diagram, and that also works the other way around. So if I double-click on elements in the diagram, I can use that to navigate to the textual source of that model. This is already nice. So this diagram helps me to get an overview on my model. It's a view in that sense that I cannot edit. So I cannot really move nodes around. When I try to, I move the entire diagram. I cannot reroute edges. I cannot add and remove nodes. And this is, well, sometimes good. For some certain types of models, that's also kind of a requirement. So it doesn't make sense, for example, to show a partial state machine. That is not very sensible. But here you already see this is a bit bloated, isn't it? So it's a bit more than we as humans find very sensitive, especially if you try to follow all the routes, all the edges. So this is a bit too much, even though the model is not big. Okay, the model is, well, 180 lines about. So this is not what we wanted. But what can we do? So let's do simple things first. This is pretty stable. I mean, it has some nice properties. It hooks into the Xtext lifecycle. So if I change the name here, it gets updated immediately. If I remove a node, an element that maps to a node, this is deleted as well. So this is something you get for more or less for free, and it's very simple. But still, the diagram is too big. What can we do? So one idea we had here, yeah, let's do some filtering. Maybe not show the entire model, but apply some filter to it. And we added a bit of a GUI that allows you to to filter the contents of the diagram by type, like leave out all the objects and associations. Then you may want to recenter the diagram. And you see, oh, this is already pretty useful, all right? This is like the class layer of that model, leaving out all the instances. And this gives me a good overview of what's actually happening in this model. You could also use other kinds of filters, like, for example, let's revert that. Look for everything that has project in its name, so like text-based filtering. And of course, you could implement all kind of rule-based ways to describe what's actually shown in the diagram without ever having to build a GUI that the user has to choose what exactly go there and manually route things. Using auto layout here, that's the Eclipse layout kernel framework, also open source, also Eclipse, also done by Miro in his PhD. So that is also a pretty good thing for us. This is already something I would say that now it's useful. Okay, I have nice ways to modify my diagram textually. That's very fast. I can check in my models. These diagrams are more or less auto-generated, so they don't require me to take a lot of manual action in order to improve that. But the customer was still not satisfied. Why? Because you could have models that span various resources and then just want to pick individual elements from these resources and unite them in a diagram, have a completely different projection than the resource split has. So what can we do? We now leave the way this kind of automation a little bit more. We add a new type of diagram, call it business model diagram. And this is a bit of a new UI. I can add files here. That looks a bit strange because they're just tiled, but I can, of course, auto layout this when I select it first. And you get this is a different resource, another file. But then you want the individual elements as well, so you need more UI, you need some kind of a model browser that spans the entire workspace. So I could now, for example, add some objects here. So let's add Miro, and let's add me, and let's relay out the diagram.
Close the side views, maybe.
Close the side panels, such that you see something. All right, so here's a diagram. It contains elements from various resources, and now I, of course, can go and say, well, this one, or maybe I don't want to see this node, I don't want to see this node, and so on. You can also delete individual edges, but yeah, that's just how you would, could add things and you can remove things. Looks like I didn't add myself. Did I want to do this?
Where are you?
Where am I? Oh, I'm not connected. Okay. That's the point, yeah. So the layout put me on top here. Okay, so there was some manual action from the user involved. I, dragged and dropped a lot of things. And of course, if the user puts some work into something, they should be able to save it. This is actually saved. You had a look at this S model before. We decided not to store the S model for persisting the diagram state because it's just too detailed. It's too much information. If you have that in your Git repository and require users to merge that, that's too much. But you still can use some, in this case, JSON-based format that just has the information the user actually modifies. And that is something that I would say at least a medium professional user is able to understand and merge if there are changes. Okay, so there are the nodes. You see they have a trace here. Whenever you store diagram information, you have to put some trace into what semantic element this belongs to. There are types of nodes and positions, and for the edges, there are the routing points. So this is persisted as a file. So now I have two files, well, in this case, even three, so various semantic models and the diagram model. And what happens if they go out of sync? And this can happen. I mean, imagine we're working with Git, and someone does a halfway merge only, or didn't even look at the diagram, or we build a bad tool and something happens. So this really happens a lot, also in other tools. So things go out of sync. Let's put a change here. there was this association. It's not this one. Crazy data spoken, isn't it? No. You have the wrong association, that's the point. Let me add the right one.
So relationships.
Relationships, associations, and that must be A1, isn't it? That's the one, but yeah, this one, okay. So this association I just added here, that one, that connects Miro via the participation to Eclipse Con, because he's a participant of that. So let's change that and say, okay, no, it's no longer Miro, it's me. What happens in the diagram? So you see that some of the edges have changed, and I get a warning marker. So these edges this one has become kind of transparent. I'm not sure whether that's, well, whether you can see it behind, but that looks a lot different from the others. And that means the underlying semantic element has disappeared. It cannot be found. And the other one, this one here, that has additional markers as well, because there has been added something that's an edge in the diagram, and it connects two nodes that are in the diagram, so it should be rendered, usually. So what we do is we do the transformation, and we see we result in a different model. Things are not recoverable, and we just mark them in the diagram. There's no automatic reconciling, because users may have already positioned things, and this is just an intermediate state. For example, I could have a syntax error in my model, such that parts of the model just disappear, and I fix that simple syntax error, and suddenly everything's there again. If I reconcile in the middle, I lose all the diagram information that was there. But now I have a UI here to say, all right, delete this and add this to the diagram. And once I do that, the warnings disappear, and I know my diagram is clean again. It's in sync with what the model does. All right, so much for the demo.
Let's leave out the incremental layout.
Yeah,
Time won't be.
I'll leave that, yeah. So I showed you 3 ways of populating a diagram. Still, that was diagram views, so no graphical editing. Well, one shown the full model. GMF coined the term canonical for that. Show the entire model. You need a mapping from semantic to diagram model, and you need the lifecycle hooks that you automatically get by Sprotty for Xtext. I showed you the filtered model, which requires a GUI for these filter rules, and you may even want to persist the rules. I didn't show that, but that works as well. They are persisted in the tool settings in this case, and this is a little bit more complex, but you need, of course, everything from the left-hand side as well. And even more, if you want the fully manual story, you need additional GUI. You need, well, the file browser in order to drag entire files, a project browser in order to drag individual elements. You need to persist because users spend a lot of time, and you need to have a story for reconciliation that is easy and does not break the tool. So usually for many modeling tools, I know it's a big problem if diagram and model get out of sync. Complexity increases. So think about it. Is that what do you really want? What do you really need? And maybe you reach your goal with a completely different story than for doing the most complex thing, what is graphical editing. Because then you just have the diagram facade in order to change your model. You need a GUI for that, and you have to sync the changes back and fro. That's going to be problematic, but I'm showing that in a minute. So this is the flow of information. The full model story is easy. I can only put changes on the semantic model, in this case the text. Our transformation runs and updates the S model. When I change, there's no way to change the model from the user side, from the diagram side. And for the filtered story, as well as for the manual story, we need an additional diagram configuration, a description of what's in the diagram, or what are the rules. And that's just another ingredient to the transformation. Still, it doesn't require us to do any semantic model changes, but the user changes are just applied to this configuration. The transformation is respawned, and this model is updated. There are cases, I mentioned the state machine, for example, where you want to show the entire model, but want to move nodes around in order to make it look a bit nicer. These are cases in which you can really consider also storing this little bit of diagram information in the semantic model itself. That works. Makes it a bit easier because you just have one file for semantic model and diagram. But yeah, it's of course not the purest approach many modelers have. So what are the takeaways here? It's a matter of what kind of interaction with the diagram you choose, whether you actually need diagram persistence, and how you do it. If you persist diagram information, choose a model. Don't just persist the diagram model, but use some reduced form of it that is human readable and can be processed with the usual text-based versioning tools. And yeah, if you go fully automated, so for these full views, you don't need any persistence. Diagram layout, I've shown you that. There's full layout, there's manual layout. There's even a mode in ELK that's a bit similar to partial layouting. I don't have time to show you that. If you're interested in that, come to our booth and I give you a demo. And finally, do you need reconciling or not? That means, can diagram and model go out of sync? For fully automated diagrams, of course not. But if so, you need stable IDEs, traces. You may even consider hook into rename refactoring and all the like. So it can be as complex as you want it to be. But do it in a way that the user has a chance to recover with a GUI an inconsistent model. All right, the next one is about graphical editing. You could think that graphical editing just works like that. I mean, if you come from the modeling world, people really like this bidirectional transformations. So instead of just transforming the semantic model to the diagram model, implement the other direction as well, because the diagram changes are kind of as model changes. When you do that, user does some change here, updates the semantic model, but then you have to be very careful in order not to run into these kind of cycles. That is one thing that can happen, okay? You don't detect that this is not actually a semantic change. You don't have to update the right-hand side. You run into a cycle. We see that often in, for example, in many frameworks that are based on model view controller, that you have these kinds of cycles and something goes bananas. You should avoid this kind of thing. What you should do instead, and I'm happy to have seen that in the GLSP as well, is translate your user interactions, your user actions, everything the user does on the diagram, into semantic operations, all right? Semantic changes. Don't try to automatically convert that back, but make it a semantic change, like in the following I will show you, into an LSP change. All right. I guess we're good in time. Unfortunately, that example broke yesterday. I'm not sure why. So since yesterday I have to run it locally, cannot show you that in GitHub. It's some node issue, but we are gonna fix it. Here we go. Another Theia, another example language, once again Xtext based. We really like that Xtext approach because, well, it's text and we are so used to text as programmers. And we have a diagram here as well. All right, this is also auto layouted, but it's, well, manual. We haven't implemented yet the storage of XY coordinates, but in this case, I would really put that into the semantic model. You see on the Xtext side here, on the textual side, you see this light bulb. The light bulb means here's a code action. This is like a quick fix in Eclipse, and that allows me to add a new state. So in LSP, that would just enter some text here add some text to the model. But there's no reason why I shouldn't use the same semantic operation that I defined here on the diagram side. And this is what we do. We have a palette. The palette asks the language server, using the language server protocol, so we're really on the textual side here, what are these kinds of actions that are available at a certain place, and then you can trigger them. This is exactly the LSP thing. There are two more things from LSP that we can actually reuse. Like, for example, I want to change the name of this node. If I change the name of this node in the textual representation, that's a rename refactoring, because that is also used for cross-referencing to that element. So we actually do not change the diagram model here, but we configure a semantic action, a rename from LSP, from the language server protocol, such that all the references to that element get updated. And last but not least, if you look at the transitions in this state diagram, they start with a cross-reference to an event, something that's defined up here. So what you would do here when you enter that manually, you would trigger content assist and get a list of possible events that could be there. And you could update Java to a higher version. Okay, so the same story here. When I double click on this label, it triggers content assist. It knows from this model, from the S model, which text offset it should use, and sends that request to LSP. Populates this quick choosing list. How is the official name? Quick bar?
Quick pick or so?
Quick pick, yeah. And then I can choose one of the things, and I introduce an error because I use the same event twice. So that is also shown in the diagram. All right, I'm almost finished. Okay, so if you really go for graphical editing, there are two things I want to, you should keep in mind. You should avoid that bidirectional mappings because of cycles and inconsistencies, and you should map the user changes to semantic changes instead, and then execute them on the semantic model. And yeah, maybe diagram editing is not necessary. So it adds a lot of complexity, and it also involves the user quite a lot. Many users like that, but it may not be the most sensible thing to spend an hour layouting a diagram when you can instead write a proper semantic model fast.
Okay, let's close. Last thing is these two questions. Please ask yourself before you start implementing something, what problems do you want to solve with diagrams? What interaction patterns are most suitable in the scenario that you're in? And really take some time to find answers together with your team, your customers, to be sure that you will really choose the right approach. And yeah, please evaluate the sessions on the webpage or app. And here's the list of links we promised. So Theia IDE, then we have the repository with Sprotty. We don't have a homepage yet. Then the dependency graph example is the third one what I showed in the beginning. The Xtext Sprotty example is the last one that Jan showed, and then 2 videos from last year's EclipseCon. Any question? No? Okay, then thanks for attending.
Thanks a lot. Enjoy the conference.